Hey guys, this is Mr. Teen Tutor here, and today we are going to be talking about a physics concept involving forces in two dimensions. Here is a sample problem. A rope attached to an engine pulls a 250 Newton crate up an 18-degree ramp at a constant speed. The coefficient of kinetic friction for the surfaces of the crate and ramp is 0.26. What is the magnitude of the force that the rope exerts on the crate parallel to the ramp? The first step of any physics problem is to underline the important information. So I've underlined 18 degrees, constant speed 0.26. And you can underline more, but I think this is the important information, including this actually. That also should be included, the 250 newtons. Now we need to draw a ramp. For whatever reason, the pen's not working. Alright, let's check this out. Alright, this is better. So here's our ramp. It's not perfect, but do the best you can. So it's at 18 degrees, and we have this crate on it. Now we need to draw the forces associated with this crate. Automatically, one force you can put in is mg, which represents the gravitational force just straight down. However, we can break this down into separate components. So we can figure out the force of this, which is mg. Man, these pens are not really working. Let's see how this works. There we go, mg cosine theta. And the force always going downward, of course, because it's gravity, mg sine theta. Now, in this problem, we're dealing with friction, and because the crate's going this way, friction will be going in the opposite direction. So friction will go what is it with these pens today? We'll go with the force of friction being right there. And when any object is moving, there's always a force normal that's perpendicular and away from the object. And then one more thing. Because there's a rope involved and we're trying to find the force exerted, that's force tension. And force tension is going in the same direction as the crate. And this force tension is essentially what we're trying to solve for. What we need to do now is break these forces up. Some forces go with the x direction and some forces go with the y direction. So even though this is not straight to you, pretend this is the x-axis and pretend this is the y-axis. Keep that in mind and this will help you out. So we're going to use this principle where the net force equals ma, mass times acceleration. So let's look in the y direction. We start with the top minus the bottom. So force normal minus mg cosine theta is equal to ma. However, because this crate's only moving in the x direction rather than the y direction, the acceleration in the y direction is 0. So even though acceleration is 0, mass, it doesn't matter what the mass is. It's irrelevant. So that's 0. Therefore, force normal equals mg cosine theta. Keep that in mind because we're going to be using that later. We're essentially going to be using a system of equations here soon. Now in the x direction, because we're dealing with three forces, you have to write this carefully. The first forces that you write are the forces that are going in the same direction as your object. So that means force tension minus mg sine theta. You can put that in parentheses. That's mg sine theta right there. Minus force of friction is equal to ma. However, in the problem, let's get it right here, it states that the object's going, rather the crate is going at a constant speed. So if an acceleration occurs when the velocity is changing, but if it's going at a constant speed, that means acceleration in this case is also 0. Now let's rearrange the equation and isolate force of tension since we're solving for that. So that would be mg sine theta plus force of friction. Here's our other equation. So now, like I said earlier, we're going to be using a systems of equations to solve this problem. So another way to write the force of friction is this. Force of friction is equal to your coefficient times force normal. So let's sub that in here for force of friction. So this equals mg sine theta plus mu, and this means mu, the coefficient of kinetic friction, times force normal. Now we solve for force normal. That's mg cosine theta. So the force of tension is equal to mg sine theta plus mu times mg cosine theta. Now let's sub in the values we know for those variables. We know that mg is 250 newtons. So this right here is 250 sine, and the ramp angle is 18 degrees. This plus, and the coefficient is 0.26. So 0.26 times, and we'll go down here, 250 cosine of 18 degrees. And we're going to perform this computation here, and we're going to get force tension, which is what we're solving for. So let's see what that is. Okay, so when I do this problem, I get 139 newtons approximately. So that is the force tension, and that is what the question was asking for. So I hope this video has helped you and answered some tips for any physics problem. As I mentioned in my video on projectile motion, draw pictures and label it with the information you know from the problem, and make sure your work is clean. Divide up the equations if necessary, and you should be on your way and get it right. Thank you.